Hey everybody, this is TJ with ShopBot Tools and welcome to today's training. Glad you could join us. Today we're going to be talking about essential cuts of CNC. A lot of these are cuts that some of you are already using, but I like to cover these different cuts in this little plaque here. Something I like to take around to the different trade shows and just show off what a ShopBot's capable of. And some of you may recognize some simple things like a profile or a pocket or a V-carve cut, but let's look at some other stuff like texturing and inlays, start depths, tolerances. So thanks for joining us today, and let's go ahead and get started. So this project was drawn in the Vectric software V-carve Pro. You could also be using Aspire. And you can see here just a simple drawing. Let me just to show you the job size. We're just working with a small 8-inch by 8-inch plaque, half-inch, and the material that is in this video is HDPE plastic. So there's our setup, and let's go over and look at the first example. And the first example we'll look at here is the fluting toolpath, which the fluting toolpath, for you that have not used it yet, is the second row down, second one over, the fluting toolpath. And I've already created one down here for this line. And the fluting toolpath, as you can see that I've named it as 0.4 deep, 0.5 ball nose. And the reason for that is it shows how deep the flute is, and it shows for the ball nose that I'm using. And just to point out here in the software, when you are doing a fluting toolpath, even though you have your start point here with the green dot, I just want to point out that the plunging of the cut has to deal with how many passes that you're going to have. So it's a little bit complicated here to throw out for the first one that we're trying to do, but you'll see here in the video, right now I have a 0.4 flute depth and I have a pass depth of 0.2. So being that this is a 0.4 cut with a 0.2 pass, it's going to do it in 2 passes. That's an even number of passes. So the way the software is set up is for an even number of passes, it's actually going to plunge, even though the start depth is here, where I want it at the shallow point, it's still going to plunge over here at the depth, make its first pass out here to the shallow, and then what it does is the second pass. And the reason for that is that second pass being the finished cut is how that was described to me straight from Vectric. So if you want the actual ShopBot or CNC machine to plunge where your start depth is, you need to have an odd number of plunges. So your pass depth would have to make it correspond directly with your flute depth and have that so it's an odd. Right now it's even. So you'll see in the video that the plunge start is here, works its way to the shallow, and then makes its final cut down to the deep. So let's look at the video and come back and explain that a little bit more for people that are having a hard time understanding what I'm trying to say here. Here we go, we make our first plunge, which is down on the deep end. It works itself shallow, and then it comes back. And that's because I had an even number of passes, 0.4 cut depth, 0.2 per pass, so it starts down there. And that's just the way the Vectric software is set up. If I wanted it to start the plunge at the shallow end, I would have to have that with an odd number of passes. So if I wanted odd number of passes, so it actually started where the green start depth is, which is the shallow point of the flute, what I would need to do here is either have it full depth or just figure out an odd number of passes. So I know my cut depth is 0.4 and just divide that by 3 equals, and there you go. That would put that in an odd number of passes. So again, just personal preference. If you want it to start right here where your actual start point is, you need to have it an odd number of passes. That's the fluting toolpath. Alright, the next one that we're going to look at is this pocket here right in the middle. And right here we have the second toolpath down is a pocket that we have set up on our list. And if you're looking for the pocket toolpath underneath tool operations, it's the second one over, pocket toolpath. So pocketing is taking out everything inside of this object here. Notice that it is named pocket 0.125 with a 3 7.5 Flute. I come in here, it's named that because it has a cut depth. So I'll stop explaining why I title things the way they are as we continue on, just for redundancy, but I want you to know that that's why I title things the way they are down here with the name, is so I know what they are for later on. I don't have to double click to open them back up. So nothing special here. 1/8 inch cut depth using a 3/8 bit that I have set up, that we have is for an ideal bit for cutting a plastic bit, and you can look at making your own custom bits as one of our other tutorials here. But let's go ahead and get this one cutting. Nothing out of the ordinary here. Zeroed our bit, and what you can see here is the pocket starting out with a ramp. So notice how it ramped back and forth, and now it's making it step over back and forth as it pockets it out. So that first plunge that I did, instead of jamming that bit down inside of the plastic, what I did was I added a ramp to it. And now what you see is the bit stepping over each pass that it goes. So this is using a 3/8 end mill that's designed just for plastic. And now the final cut here is it makes a last pass all the way around and cleans up the edge. So let's go back and look at the drawing file. And within the pocket here, you could see that we had a ramp right here. It was checked, and what that does is, you see in the video, is it ramps the bit down in. And you can also see up here that I had a raster chose where it did a profile pass last. I prefer to use a raster when I'm going back and forth with the grain of certain materials, of say wood or plywood, so I don't rip that veneer. Sometimes with plastics or aluminum, we'll tend to go to the offset cut. You'll find a personal preference, and look into this further with the specific material that you're using. So this was just a basic pocket cut right here. The next one we're looking at is the word ShopBot here, our logo, and that is carved, V-carved, down inside of this pocket. So instead of down here like the star where it's just carved into the top surface of the material, this one's carved down inside. So we'll use a start depth on this one. So right here you can see it was imported in the ShopBot logo or the text that you choose. Over here we have V-carve text 90. If you're looking for the V-carve toolpath, it's the second one down. It's the giant V. It says V-carve engraving toolpath. And notice when I go in this one that all the stuff here is grayed out, because the V-carve toolpath takes care of fitting the bit geometry down into the different widths of the cut. So you can look into that deeper underneath some of the help tutorials or help contents up here. But what I'm pointing out for today's example is, notice we have a start depth. With a 0.0 start depth, which is default, the word ShopBot would actually be just cut into air. Our logo would never show up because there's already, from a previous toolpath, a pocket that's been cut out. So this is why we have that start depth of 0.125, 1/8 of an inch. And that's why when that one was calculated here, you can see the first one was the pocket, which is what we just watched the video, and now the V-carve toolpath is actually pushed down inside of this. So if it was at the default 0.0 start depth, we would never see what it looks like. So the start depth is set at 0.125 because the previous cut was the pocket of 0.125. So we're giving it a start depth. So for a lot of you that have never used a start depth, I hope that explains what that is, because now I'm starting that cut down inside of the previous pocket. Let's take a look at that out on the video. I'm just pointing out here that we're zeroing the Z on the material surface. Nothing has changed there. We still zero in the normal spot, even for this kind of a cut depth. Now we make the cut, and it has the start depth of 0.125. So you didn't need to do any fancy re-zeroing or anything. You just zero the Z in the same spot as you normally would on the material surface where the file is set up. And here we have a start depth of 0.125. So the machine knows just cut down in there, and it knows to pick up and move around. So when you're not cutting down inside of that pocket or other pockets, it would pick up and go into the appropriate safe Z height. Really awesome part of the software. Really shallow example right here of the 0.125, but this works on a lot deeper cuts as well. The next one that we're going to look at is the star down here in the bottom right corner, and this is simply a profile on the line. And I like to point this one out because a lot of people that are just starting out think profiles are only through cuts for cutting things out, like this square or this T up here. But a profile can also be used for just cutting down to a certain depth. So instead of pocketing out like we did earlier here, we took all the material out in between. A profile again just cuts along the line. So let's take a look at the star. So the profile toolpath is the very top left corner here, and you can see profile on the line for our star in the bottom right corner. And this one just has a shallow 0.03 cut depth. I'm using the same V90 as before, so there's no need to re-zero the Z. And I'm machining on the line. So it's taking that V bit. You can see the little yellow ball here, example. If it goes to the inside, the outside, or it machines on the line. Really a neat feature that the profile toolpath is able to do. So let's take a look at that on the ShopBot. And we can see the V bit come over, start making the star, and it's just cutting on the line. That's all it's doing. Taking that V90 bit, centering it on the vector and cutting that out. Well, the next one that we're going to look at here is the texture toolpath, which is right here around where the T is. And this one uses a ball nose. And for this example, we're going to use a 1/4-inch ball nose to leave a texture. The texture toolpath is one of my favorites. It's the second row down, third one over. It says right here, texture toolpath. And what's neat about it is it makes really beautiful wood grain. But for this example, we're actually doing it on plastic, and it still looks pretty neat. What I like about the texture toolpath, I've already got one created down here, so I'll double click on that, is you can come in here and set this texture up to whatever your little heart desires here. This thing is customizable to whatever it is that you or your customer is looking for. You can set your cut depths, min and max, cut length, min and max, step over percentage, and angle. You can even give it an angle. And what's nice about this, when you find a texture that you like, you can calculate it, preview it, make sure it looks right, and you can save it. So maybe you're doing a set of signs for a golf course, and you have 18 holes, and you want to have the same texture on each one, just a different number goes on each sign for the 18 holes. You can load up that same texture and keep reusing it for all 18 signs. So let's take a look at how the ShopBot cuts out a texture toolpath. So the texture toolpath is just like a hit or miss. It just comes down in, does its little step over. You can see that it is at the angle that it was set up for in the texturing toolpath. I will warn you that big signs, when you're using a textured background, it does take a while. I mean, look at what it's doing. It has a small step over, and it's a series of X, Y, and Z pickups and moves. So, but it does look cool. It even looks great here in this piece of plastic. You can make that hand-carved look on darn near any material here. It's pretty cool. So this is the texturing toolpath. Again, without going into really zooming in, you can see there is a little bit of material that's left. So I will tell you that with the texturing toolpath, just with the step overs, that sometimes there is a little bit of sanding required. It's not much. If you have a little slap wheel on, say, a Dremel, that'll get any of those little burrs or furries that you have left over. But simply enough there's the texture toolpath. And as any of these toolpaths that I'm showing you today for the essential cuts, if you haven't done any of them before, don't do them for the first time on your project. Try them on scrap material and practice with them before you actually put them to use on a paid-for project or something that you're going to use. Alright, this next one that we're going to look at is the inlay toolpath. So if anybody has not done an inlay before, what it is really a male profile cut, which is the T right here that's going to be cut out, and then your female, which is your pocket that the T fits into. So just looking at a basic inlay. So a male, female, a mortise, a tenon. Everyone has different names what they call these things, but we're just going to call it what it is. It's an inlay. So this one here is a raised inlay where the T is actually sticking up out of where we just textured. So let's start out by looking at the vCarve drawing file for this. So the inlay toolpath is right here on the top row, far right over. It's a little eye inside here. It says inlay. And when you click on it, it's asking you to set up both your male and your female part. So the actual part that's being inserted and the part that's being pocketed. So this right here on the right is our insert, and this right here is our pocket or our hole if it was to go all the way through. Notice I've made a point of making these with square corners. We're going to be cutting these out with a 1/4 inch round bit. How do you cut square corners with a round bit? Well, in this example, you don't. You can't have a square corner doing it the way we're going to do it. There's other ways of getting around things with, say, a vCarve inlay. But today, what I want to show you is the power of this inlay toolpath. Knowing that I have a 1/4 inch diameter bit, let me start out here with the first one with the pocket inlay. So the pocket inlay, female inlay pocket, what it does is I set it up just like a normal pocket toolpath. But what's really nice about this feature here is it will take this 1/4 inch bit and it will mate it to these corners and know where it needs to make those corners round. As long as you use the same diameter bit for the male portion, again 1/4 inch upcut bit right here that I'm going to be using for this, what it does is it also mates the corners to this. So if I take these two here and I turn them on, you can actually see, if I turn on the purple up here instead of the wireframe, if I have the pocket and the profile, what you can actually see is it takes my square cornered vectors, and what it does is it puts the rounded edge to them. So you can see here on the male portion that comes out, it knows to cut to the inside of an outside corner, and it knows to stay to the outside of an inside corner. Say that 10 times really fast. But you can see exactly what it's doing here with the purple. So again, up here the wireframe, I can turn this, turn that on or off, and you can see what it's doing. The toolpath, that purple line is where it's actually cutting. And notice over here too on the pocket, why is this purple line to the outside of the vector? And that is so that this thing actually fits together with a little bit of up and down, a little bit of tolerance to it, a little bit of play. I'm not actually gluing this in. This is an example for people to put their hands on and pull the part in and out. So this pocket right here that you see, the female portion, pocket inlay, actually has a tolerance to it, which is called a pocket allowance of 0.01. And that 0.01, when it says 0.01, is actually 0.01 on each side. So this overall has a tolerance of 0.02. So let me just clarify that one more time for people that have not used this. Pocket allowance 0.01 doesn't mean it has an overall allowance of 0.01. It's sticking out on this side by 0.01. If you were to use your measuring tool and get this exact, you would see exactly that that's 0.01. 0.01 right here is your distance. So when you have a tolerance that you add into your toolpath, your pocket allowance, tolerance, whatever you want to call this, just make sure you know that it's doing it to each side, so it's going to double that number. Let's take a look out on the ShopBot here and see if we can make a little bit more sense of what we're doing by seeing this thing cut. Here we go, making our first plunge down in, and we can see here that it is cutting out the pocket. Nothing more than a pocket toolpath like we saw earlier. It's doing it in 2 passes. There's our pass depth. And notice that it has the rounded corners. Even though the vectors are square, the inlay toolpath automatically adds the radius to it. And now we come over here and do the male portion that's going to be cut out, and then at the end of the training here I'll show you how that fits with that tolerance. But it's adding the tabs, and notice that this T also has rounded corners both on the inside and the outside, due to the inlay toolpath doing what it's supposed to do. Let's look down in the bottom left corner here. We got 3 different holes, and a lot of early on mistakes that people think is that's 3 different bits. But what we're doing is 1 bit here, 1/4 inch diameter bit, and we're going to use the pocketing toolpath to do all 3 of these holes. Really, this bottom left corner is just a simple one to show people that are first getting started into this. You don't need to change bits. This is just another pocket toolpath. Instead of a pocket only being cut to a certain depth like we did earlier here, you can use the pocket toolpath to do through holes. So if I click on this, you can see pocket toolpath. There's my 3 vectors, which are 3 different size circles, and I'm just going to be using the pocket toolpath to go in. And I choose to use the pocket because you get into too big of a hole. If you use a profile, it's going to leave material in the middle, and you'd either need to tab that so it didn't fall out, or so the pocket toolpath would clean out this stuff. So let's take a look at this one on the ShopBot cutting. Here comes the bit over, starts with a small hole, does this 2 different pass steps. Here you can see that it works itself around by first cutting out the middle and then doing a finish cut around the edge. So that's where the pocket toolpath is really nice for these small type holes. It takes out the middle that would fly out of there if you were just doing a profile. It starts in the middle, so there's no material that would pop out. This next one we're going to look at is just like an inlay, but I want to point out how you keep something square. How do you actually cut a square corner with a round bit? So here's our square in the blue, and then over here I modified it a little in the yellow so you could see how it fits down in the pocket, using something called either a dog bone or a T-bone fillet that is added to the vector in the software. So nothing fancy going on here. We're just looking at a pocket toolpath and a profile toolpath that we're cutting that we've already looked at. But what I wanted to point out here is to get this pocket over here to fit this male portion, there's no way it's going to fit with this corner right here. It's a square corner, but you have a 1/4 inch diameter bit that you're cutting this out with here, 1/4 inch bit, which is 0.25. That's the type of corner that it's actually going to leave. So what you need to do is, you can see that I've added a dog bone and a T-bone, so you can see the different types. And this, let me just turn these off here so we can see a little bit better what we're looking to do. What we're doing is underneath the Filip command, edit objects, 3rd one down currently in the software is Filip Commands. You would type in the radius of your bit. We do know that the diameter is 0.25, half of the diameter is the radius, and a normal fillet is just going to do what the bit would do, that rounded corner. Now we can't get a square corner in a round bit, so I can click back on it and get rid of it. Or what I could add here is what you see is a dog bone, which is this upper left corner, or a T-bone, and I've made a point to show you that a T-bone can either be added to the side or up and down. And at any time, if you don't like them, you just click on them and add them where you want them to be. They don't have to be the way that they originally were in a file. You can take them out of there, and you could make them all dog bones if that's what you wanted to do. Quarter inch bit comes down in, and it cuts out the dog bone or the T-bone depending on how it is that you drew them. So there you can see the dog bones, you can see the T-bones. There it is for the pocket portion, and then here is our actual square. We can keep the square corners right here on this profile cut. So let's pause and actually look at these inserts here real quick. So there's the ones we just cut with the dog bone, and there's our inlays from up above. So if I clean off the tabs with the sander, I did them out of yellow so it shows up a little better on the video. There's that tolerance up there. It fits in and out nicely. And then down here you can see adding the dog bone or the T-bone to the pocket. I made a point of leaving the one corner round so it only fits in there one way. But those square corners now fit because of the dog bone and the T-bone. Pretty neat feature, those fillets. And really nice to have the tolerance in there too. So remember offsets, remember fillets for whenever you have a male or a female profile pocket that needs to go together. And the last thing we should look at is actually cutting this 8x8 plaque out. And the point of this is I want to focus on tabs a little bit so you can make sure that you're adding in tabs to keep that part from moving while you cut it out. A tendency if you forget to do tabs is that part's going to shift while cutting. You could either snap a bit or the material could move into the bit and actually damage the piece of material that it is that you need for your project. So the last one here is a cutout, which is our rectangle here. I actually, in the video, have a larger piece of material that this is being cut out of. But just for this example, just to show you what it is, it's nothing more than our profile toolpath. We've seen that a few times now. But what I wanted to point out is that you've actually added a tab feature. So whether you're using the advanced or the non-advanced, you do need to have a tab added. And the tab is what keeps that part from moving. And you can edit tabs by going in here to edit tabs, and that allows you to place them. Wherever you hover over, there's a check mark, and that allows you to place a tab there. And if you no longer want the tab there, get rid of it. And I'm pointing this out because for me, I prefer not to have tabs in a place that the CNC machine has really used its capabilities to cut, say this half-inch radius end. Now if I put a tab right there and I have to go and clean that up, am I going to be able to clean this up as nice as the CNC machine? And you could rebuttal that by saying same thing with a straight line, but I'm talking about more intricate parts like this. Like if you were to have a tab down inside of a star or inside of one of these dog bones or right here on the end of a corner, you're never going to sand that the same. So all I'm trying to point out is tab placement. Put them in a way that's either gives your cut strength or keeps it from having lots of work to have to do when you clean it up at the end. I like to have my tabs running parallel, personal preference, easier for nipping them off at the end. I kind of got a little system where I know where they're at and I go for cutting them off. And let's go ahead and just see this last one being cut out. So you can see for this training, I just did this out of a scrap piece of HDP that we had. So our 0, is just a temporary 0 in the middle here, and that's how I was able to get it to fit on this project. But it's going around doing its first pass, and then I wanted to see here when it goes down to its second pass, it comes around the front here. I wanted you to notice the tabs where it lifts up, goes down, up and down. It has the 2 tabs on the front and the 2 tabs on the back, and that's what's keeping my piece from kicking out or moving at that final through cut. So tabs will hold that in place. Then once the cut is done, you do need to remove the tabs. You just use a chisel here in place, or I'll take it off, flip it over, and nip it with the utility knife from the back side. And then whatever little tab remnants left, that's where you do need a sand, or I like to take it over to just a flush cut router and just put a straight edge on it, and that way it doesn't leave any debris or any machine marks. And there you go. There's all of our different cuts that we just went through for the essential cuts. It's pretty wild to think how many different cuts are just in this little 8-inch by 8-inch plaque, and we just scratched the surface of different cuts that you can do, but these are the top ones that I thought were essential to getting you going. We started out with a flute where you can start from one depth, cut down to the next, and leave it like that. It's just like a ramp is what it looks like. And these are really nice for decorative trims or cutting boards. Say you need a juice groove to go around, you can send all the juice down to one end. So there's your fluting toolpath. We did several pockets throughout today. We did them where they were not only just a pocket to a depth, like right here where the ShopBot was, but we did a through pocket over here with the holes. We used the Inlay toolpath to do a male and a female part, which is a profile toolpath and a pocket toolpath that fit together. The Inlay toolpath in the software allows it to mate together with the bit. You just make sure that you select the same bit for both the male and the female portion of the inlay. We look at a lot of stuff here: textures, tabs, start depths. It's a great training to show you the different essential cuts to get you going with CNC. If any of these types of toolpaths are new to you and you'd like to look into a little bit more further explanation, there are other tutorials and trainings. There's a full training, 30 minutes, on just how to do inlays. So between our website that has lots of different training tutorials and the Vectric website, which has a lot of how to use the software and set this sort of stuff up if you're not familiar with the CAD portion, between those two resources, I would check them out. Get out on your machine and practice with some scrap material. Just start collecting scraps and cut-offs. Go around to different shops, whatever you need to do. But practice this stuff before you actually put it out on a finished product. So I hope today's training was really beneficial for you and get you going for different essential cuts that can be used on your ShopBot machine. Thanks everybody, and we'll see you all next time.